What we're looking at in this video is binary addition. So how we add together two binary numbers. And it's exactly the same method as how we add together with denary or decimal numbers, except we're just using ones and zeros. So in some ways it's actually easier. So let's start off with a number here, and this will be the number that we start with. So that's 0, 1, 1, 0, 0, 1, 0, 1, and another number which we'll have, which is this number. So the first thing which we do, there's actually two ways to do this, but I'll show you the first method of doing it. And so we say 1 plus 1. Now that would be 2. So if I was putting the answer here, it would be 2, except it's binary, I can't do 2. 2 is 1, 0. So I'll carry the 1 and I'll put 0 down here. 0 plus 0 plus the 1 which I carried over is 1. Now I've got 1 plus 0, which is 1, and 1 plus 0, which is 1. 0 plus 0 is 0. 1 plus 1 is 2 again, so I need to carry the 1 and put the 0 here, because 1, 0 is 2 in binary. I've got a 1 and a 1, so again that's going to be a 0, carry the 1, and then 0 plus 0 plus 1 is 1. So what I've got here is 3 zeros, 3 ones, and a 0. Now we can check to see whether this is actually correct or not. So I can translate these numbers into their denary equivalents. So I've got the 1s, the 2s column, 4 column, 8 column, 16s, 32s, 64s, and 128s. So this is 1 plus 4 plus 32 plus 64. So that will be 11, and then 6, 9, 10. So that figure there is 101 in denary. And this figure here, I've got a 32 plus an 8 plus a 1. So that's 41 in denary. And so now I'm going to look at what my answer is. So I've got 128 in my answer, plus an 8 in my answer, plus a 4 in my answer, plus a 2 in my answer. So we've got 8, 16, 22, and we've got 2 there, plus the 2 which we carry from the 22, so that's 4, and the 1. So the answer which this represents is therefore 142 in base 10. So what we need to do is, if we add these two numbers, so that's 101 and 41, so 101 plus 41 is 142, and 142 matches the answer which we got in binary. So we can use two methods, and therefore we can check that our answers are correct. So now what we want to do is add the following numbers in binary. And so easy part first, we just add up the two numbers exactly as it says. So what we're doing is 1 plus 0, which is 1. 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 And I think you get the idea. So we can add all those down, and so they all become 1s. And we know that that number is 255. When they're all 1s in one byte, the number is 255. So if we just check, we can see that we get 255. So what is this binary number in base 10? So first of all, put in what the columns are: 1, 2, 4, 8, 16, 32, 64, and 128. So we are checking the first column, so that's 128, that's 128 there, plus 32, plus 8, plus 1. So 8, 16, 17, 18, 19. Carry the 1. 3, 5, 6. So the answer is 169 for the first number. Second number here is 64 plus 16 plus 4 plus 2, and so that number is 10, 14, 16 plus 678, so that number's 86. So we're looking for 169 plus 86, which is 5, and 6, 7, 15, and 1 plus 1 is the 255, and these numbers here are the same, so both methods show that we're getting the answer of 255, so we know we're correct. Let's look at the second problem. So the second problem here, we need 1 plus, and we're adding again, so 1 plus 0 is 1, 0 plus 0 is 0. 1 plus 1, this time a little bit harder. So 1 plus 1 is 2, but we don't have 2 in binary. 2 is represented by 1, 0, so carry the 1 and a 0. 1 plus 1 is 2, so it's 1, 0 again. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1, we need to carry the 1 and put 0 in there, and then 1 plus 0, and we get a 1. So now we just want to double check this. So this number here, and remember 1, 2, 4, 8, 16, 32, 64, and 128. So we've got 64 plus 32 plus 8 plus 4 plus 1. So 6, 10, 18, 19. Carry the 1. 6, 9, 10. So that is 109. And the second number that we've got is a 64 plus 4, which is 68. So we're doing 109 plus 68, which is 17. That's a 7, and that's a 1. And so we've got an answer of 177. And so we just need to work out what the answer was. So we got 128, that's this one here, 128 plus 1 plus, 128 plus 32 plus 16 plus 1. So we've got 10, 16, 17, and we got 3, 5, 6, 7, and we got the 1. There we go, 177. The two answers match, so we were correct. And finally, looking at number 3. And number 3 is an interesting one, and we'll see why as we start to get the answer. Remember, these are 2 bytes that we're storing here. And so we're going to add these up together. Start off easy. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1 is 1, 0. 1 plus 0 plus 0 is 1. 1 plus 1 is 1, 0. 1 plus 1 is 1, 0. 1 plus 1 is 1, 0. And then we've got something interesting here, which is 1 plus 1 plus 1, which is 3. And if you remember, 3 is represented by 1, 1. So we get a 1, carry the 1, and then we've got 1 plus zeros that aren't written here, which is a 1. So this is our answer here. And we just double check that this is correct. So we take this number off to the top and put in what the columns are. 1, 2, 4, 8, 16, 32, 64, and 128. So we've got 128 plus 32 plus 16 plus 4 plus 1. So that's 10, 16, 21. Carry the 2. 2, 5, 6, 8, and the 1. So 181 is our first number. The second number which we've got is 128 plus 64 plus 16 plus 4 plus 2. So 8, 12, 18, 22, 24, and 8, 9, 11, and 1 plus 1 is 2. So 214 there. If we add these two together, we've got 181 plus 214. So that's going to be 5, it's going to be a 9, and it's going to be 3. So our answer and target that we're looking for is 395. And so if we look down the bottom, we've got, and just let's do that up here. So we're missing a column which is 256 here. So we've got 256 plus 128 plus an 8 plus a 2 plus a 1. So that's 14, 22, 24, 25, 5, 6, 7, 8, 9, and 3. And there we have it, 395, which is what we have here, 395. So both systems of working it out seem to check out. Now this one, number 3, presents an interesting problem, because if we have 2 bytes, so this one here, so what we have in this part here, that is 1 byte of information. So we've got 8 bits, 1 byte. And here we've also got 8 bits and 1 byte. But if we look at the bottom one, 8 bits would be here. And so what you get is, if we were to work this number out, remember our answer is 395, but this answer here, which we'd have, if we were storing this inside 1 byte, what we would actually have would be 128 plus 8 plus 2 plus 1, which is 16, 18, 19. And then we'd have the 2 and we'd have the 1. So the answer we would get if we did this would be 129 rather than 395. And so if we add 2 numbers together and the result is too big to store it in the 255 which we have available in 1 byte, then what we get here is this bit overflows, and what we get is an overflow error. And if we don't check to see whether we have an overflow error, then instead we'll get the wrong answer. So you need to be careful on that when you're working with binary numbers and a limited space to store them.